G'day, Year 7s. Alright, today we are looking at calculating the mean of a set of values. Now, the first thing to understand is that mean is simply a fancy mathematician's word for average, and we all know what average means, okay? So how do you calculate the mean or the average? Well, the mean of a set of values is the sum of those values divided by the number of values. Now, sum of those values, that simply means you take all of your values in your data and you add them together and you get an answer. Now, the number of values is exactly what it says, how many values are in your set of data. And you can figure that out just by counting. And if you divide the sum of your values by the number of values, you get the average, or what we're now calling the mean. Very, very simple. All right. If that didn't make any sense, I'm pretty sure it will in a couple of seconds because we are going to do some examples. Example number 1. Find the mean of the following values. So, here we go. Mean, wait a minute, I don't want orange, I want purple. Mean equals, okay, so first we have to find the sum of these values. So that just means add them together. 3 plus 6 plus 5 plus 3 plus 8 plus 8 plus 7 plus 9 plus 3. And secondly, we have to divide that sum by the number of values that we actually have. Well, how many values do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values. All right. Now, I could draw an enormous fraction line and put a 9 on the bottom, but that looks kind of messy to me. So what I'm going to do instead is put the sum in brackets because that needs to be calculated first, and then a division symbol and 9, the number of values. I think it looks a little bit neater that way. All right, so let's line our equal signs up. Now that big sum in brackets equals 52. Okay, and we bring the divided by 9 down to the next line. Now we just have to calculate 52 divided by 9, which is 5.7777 recurring. Now I'm going to round to, let's say, 2 decimal places. And let me just scribble here for a second. We have a bit of a rule. If I have 5.7777, etc., ... and I want to round to 2 decimal places, then I have to look at the third decimal place. And if the third decimal place is 5 or more, then I add 1 next door, which means the 7 goes up to an 8. So just remember, 5 or more, add 1 next door. Okay. Scribble, scribble, scribble. So 5.7 recurring becomes 5.78. Now, technically, it doesn't equal that exactly. It's approximately that because we did some rounding. So I'm going to use squiggly brackets, which means approximately equal to. Okay. All right. On to our second example. All right, here we have a practical sort of real-world question. 5 friends write down their results for a recent maths test. Here is the list. All right. Tom did very well, 40 marks. Well, depends what it's out of, I suppose. Sam did reasonably well, 30 marks. Dave, poor old Dave, got 0 marks. Marie, 20 marks. And Bart, 10. Calculate the mean number of marks. So we are going to use the exact same process. All right, here we go. Mean equals, it is going to be the sum of 40 plus 30 plus 0 plus 20 plus 10. All right. divided by the number of values that we have. Well, how many values do we have? We have 1, 2, 3, 4, 5 values. All right. Now this sum, 40 plus 30 plus 0 plus 20 plus 10, equals 100. We bring down the divided by 5. And what's 100 divided by 5? Well, it's 20. It's 20 exactly, so we don't need a squiggly equal sign and approximately equal to sign this time. We're just going to use a regular equal sign because it equals 20 exactly. 20 watts? Well, 20 marks. And because this is a sort of real-world question, we need to write a little conclusion. Therefore, the mean number of marks is 20. And it is as simple as that. All right, one more question. All right, for our final example, we have a slightly trickier situation because we have our data displayed in a frequency table. Now let's look at the question. Using the following table, the following frequency table, calculate the mean number of siblings of students in Miss Peters' class. Okay? All right. Well, let's have a look at this table. The first column says number of siblings of students in Miss Peters' class. So each student in Miss Peters' class has a certain number of siblings, okay? Now the next column says frequency, all right? That is the number of students in that class that have the corresponding number of siblings. So in other words, 10 students have 0 siblings, 8 students have 1 sibling, 4 students have 2 siblings, another 4 students have 3 siblings, and 1 student has 4 siblings, okay? So that's how you read a frequency table. Now, how can we extract the information we need from this table to calculate the mean? Well, one way to understand this is to rewrite this table as a list of data, just like the lists that we've been dealing with in the first 2 examples. So, let's have a look. If I wanted to rewrite this as a list of values, I would have to do the following. So, let me change colours momentarily. Okay. All right, so 10 students have 0 siblings. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. 8 students have 1 sibling. Okay, so I'm going to do 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. 4 students have 2 siblings. Okay, so I'm going to do 4 twos. 1, 2, 3, 4. Another 4 students have 3 siblings, so that's 4 threes. 1, 2, 3, 4. And 1 student has 4 siblings. 1, 4. Now, if I add all of these numbers together in this list that I've created, I will have calculated the total number of siblings of all students in Miss Peters' class, okay? So let's think about how we would go about adding those together. I would do, well, the sort of, the less clever way to do that would be 0 plus 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 1 plus 1 plus 1 plus 1 plus 1 plus 1, blah, 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 blah. Just plus signs between all those numbers, okay? And you'd get the right answer. But think about it. There's an easier way to do it. How many zeros have I written down? I've written 10 of them, okay? So 10 lots of 0, 10 times 0. Plus, how many ones are there? Well, there's 8 of them. So 10 times 0 plus 8 times 1. And we continue in that way. plus 4 lots of 2 plus 3 lots of 4 plus 1 lot of, plus 4 lots of 3 and plus 1 lot of 4, okay? And what would we get? We would get 32 siblings. All right, and the number of students, okay? Well, if you think about it, each one of these numbers that I've written in this list represents one student. This student had 0 siblings, this student had 0 siblings, this student had 0 siblings, and so on. So each one of these numbers represents a student and how many siblings they have. So the total number of students in Miss Peters' class must be the same as the total number of numbers or values that I've written in this list, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 27 students. There we go. So now we have our two values that we need to calculate the mean or the average. We have the total number of siblings and we have the total number of students. We're going to do 32 divided by 27. But that was a very, very sort of roundabout way of doing things. We have a much cleverer way that we can do this if we just use the frequency table a little bit more cleverly. So let's take a look. All right. So what I've done here is I have created a f times x column. All right. That's the frequency times the number of siblings. So let's fill in that column. F times x, frequency times x, which in this case represents the number of siblings, all right? Okay, 10 times 0 is 10, 8 times 1 is 8, 4 times 2 is 8, 4 times 3 is 12, 1 times 4 is 4. Now, if I add all of those numbers together, what do I get? 32, okay? And I'm going to use a bit of a fancy symbol right now. That's a Greek symbol, capital sigma. It means sum, it means add together. Adding together f times x, the values in that column, and I get 32. Well, what happens if I take the sum, if I add together the values in the frequency column? Well, 10 plus 8 plus 4 plus 4 plus 1 equals 27. So 32 and 27. Let's take a look at the way we did things on this page. And we've got the same numbers, 32 and 27. But I think we'll all agree that by using the table, it was a lot easier, a lot quicker, and a lot simpler. All right. So here, now we're ready to calculate the mean. So mean equals the sum of all of our values, 32, divided by the number of values, 27, which equals 1.19. And once again, I've rounded to 1.19, so I'm going to use a set of squiggly brackets, which means approximately equal to 1.19, okay? Now I've kind of run out of space here, but because this is a worded question, you really need a conclusion. Let me try and squeeze it in. Therefore, the mean number of siblings is 1.19. Okay, so I suppose the moral of the story here is that when you're dealing with frequency tables and you are asked to calculate the mean, all you need to do is add a third column, the frequency times value or score column, the f times x column, Fill in the column, take the total of the frequency column and the f times x column, take the sum of the numbers in those columns, in other words, and then you do the number in the f times x column down the bottom divided by the number in the f column down the bottom, and you will get the mean. All right, hopefully that made some sense. I know it took a little bit of time. Thank you for paying attention, and I'll see you next time.